Hey YouTube, welcome back. Today we'll talk about streaming. In system design, streaming refers to the continuous transmission and processing of data, typically in real time or near real time, as it generated or received, unlike traditional batch processing, where data is collected, stored, and then processed at a later time. Streaming handles data on the fly often as it created. This approach is crucial for scenarios where immediate data processing and decision making are required. So let's talk about that. We have basically two types of of connections. We have the pulling. Um, we have pulling. Let's say that no. We have pulling. Let's say that we have the server here, and we have the client. We have the client here, and basically the pulling, it will be the client will ask for the requests and the server will send back the response, and this we call pulling. um, and it works perfectly fine for a lot of applications. However, streaming is quite different. Basically, whenever the client needs the request, the client has to ask the server for the request or for the data, and the server then will send the data to the client. In streaming, it's quite different. So let's say that we have the server here again, and we have the client. Basically, streaming, it's a continuous connection between the server and the client. So basically, let's try to type it right. So basically here, whenever the server got new data, it will send it directly to the client. The client doesn't has to ask for it again. So basically, how it works is that we have data source. For example, streaming systems often handle data from various sources such as sensors, user activities, or websites or apps or financial transaction, or maybe social media social media feeds. This is continuously generated and needs immediate processing. For example, let's say the client is looking at a social media feeds, for example, on Facebook or something like that. We have continuous ingestion. So the streaming system continuously ingests data as it arrives. This is contrast to batch processing, where data is incised in chunks and schedule intervals. So let's say that we have another client that add posts, and this post will be added to the database from the server and the client is reviewing the news feed, and the client needs to see the new post, so the streaming servers will send it directly because we have a continuous ingestion. In the real time, we have also real time processing. So once ingested, the data is processed in real time. This can involve various operations like filtering, aggregations, enriching, or analyzing the data. The processing logic depends on the application's requirements. After that, we have the output. The output of the streaming system can be used for immediate decisions, making alerts, or real-time analysis, maybe in dashboards, or maybe the client can see a new post here. Okay, so let's talk about why do we need streams. So let's go back. So why we need streaming? So we need it for real-time insights first, because streaming provides real-time or near real-time insights into data. This is crucial for applications where timely information and quick response are critical, such as fraud detection, monitoring system, and real-time analytics. Or maybe you have your application, and you are an Uber, and you're just looking to your driver location, so you need to have an immediate update or near real-time update of your driver location to know if your driver is closer than you or not. It's great when it comes to scalability, because streaming systems can handle high volumes of data and are scalable to accommodate varying data rates. This is essential for applications that deal with large and continuous streaming of data. It's great when it comes to efficiency. So by processing data as it arrives, streaming systems can be more efficient than batch processing, especially when the volume of data is large or when the data is time sensitive. It's great when it comes to flexibility also because a streaming system can adapt a different data formats and structure, making them suitable for diverse data source. Let's talk about what are specific applications that we try to use, like it's you are more likely to use when it comes to streaming. First, you can use it in a newsfeed system. You can use it also in you can use it in a chat system, like when two people are talking, you can use it in the chat. It's like where is Shine streaming Shine in chat system. It's great when it comes to using in an Internet of Things. So if in IoT applications, streaming is used to process data from numerous scenarios and devices in real time. It's a great for in financial services. So streaming is used for processing transactions, stock prices, and for fraud detection in real time. It's great also in social media. As I said before, streaming technologies analyzes social media and data as it is generated to gain insights into trends, user behaviors, and posts, etc. So in summary, streaming is in system design is a vital for applications that require real-time data processing and analysis. It enables organizations to act quickly on data, provides scalability to handle large volumes of data, and offers the flexibility to handle a various of data sources and types. Of course, streaming is not all the time better than polling. There are some times polling will be better suited or like a better decision to use instead of streaming. This is depends on your system requirements. I will make a dedicated video about polling and another video to talk about only streaming and polling and what are the differences and when to use what. So yeah, that's it for today's video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bells so you never miss a video, and see you in future problem.